concept of AI is really not new. It's, thanks to the entertainment industry, we all see movies with AI in it. They always portray these AI as, these super smart humanoids. They work super fast, remember everything. They can work 24/7. They always learn and get smarter every single day. And what's even better is that they never get tired and never complain, right? So they're almost like the perfect employee. Like, I mean, I would love to have someone who's like that, to work for me. So yeah, so I don't have to do as much work. But this understanding of AI is actually, I would say, pretty shallow. And in fact, if just that's understanding of AI, it actually won't help business leverage the full potential of AI. Instead, it actually creates a fear, right? It creates a fear that, when will AI replace us? Obviously, they are a much better employee than we are, right? Or we can ever be, right? So I mean, so this is, so if we have this fear for AI, then obviously we are not going to be, want to use it, and as a result, we won't be able to leverage it at its full potential. Okay, so how can we understand AI from a more practical perspective to understand it in a way that enable business application? So we have to kind of step back a little bit and understand a little bit of the history of AI and why does it come about, and that goes all the way back to business analytics and business intelligence. Okay, so so let me just use a toy example. Just let me minimize the screen for a sec. Okay, good. Yeah, because let me just use a toy example of these stock trading data that you all have seen, right? And to illustrate this brief kind of history of business intelligence. So first, when you get data, right, you obviously look at the numbers, right? But when it becomes too many numbers for you to look at, what do? Right? Obviously, you compute some kind of a summary statistics, right? You compute some kind of a indicator or some, means and average and trends, local trends, and so to tell you a little bit about this data set, right? That's often too big for us to look at every single number, right? To make sense out of it, right? So all of this is what we call descriptive analytics, right? Descriptive analytics is all about describing the data that already exists, right? So it's about in fact, it's about summarizing data that already exists so that you can have a better sense of what they are, right? But after a while, when you do this summaries, descriptive analytics for a while, you start to realize some pattern. You say, oh, that's interesting. I could build a model for this set of data. Right, so once you build a model, you have a model, right? But having a model, what's the beauty of having a model? The beauty of having a model is that you can actually now extrapolate to regions where you don't have data yet, right? In this case, since it's in what we call a temporal predictive problem, right? The extrapolation is to the future, right? Which you don't have the data, right? And then that's when you actually move into what we call predictive analytics. Predictive analytics, when you do that, you obviously continue to do your descriptive stuff, right? You continue to do this summary statistics, right? But one thing that's really good about having the eye into the future is that you can actually prescribe actions for people to take as well, right? So if you want to, maximize return on your portfolio, this is a good time to buy, right? And when you start prescribing actions for people to take, you move into what we call prescriptive analytics. Okay, and obviously, you could prescribe more than one action, right? And you obviously continue to do your predictive and also descriptive analytics, right? But your prescriptive analytics system can be pretty smart. It could actually tell you, can actually prescribe not just one action, but a sequence of action, right? For example, buy here and then sell 50% there, continue to go up, sell another 50%, right? So actually could prescribe a sequence of action as well, right? So most of the business analytics, right? So this is basically the history, very brief history of business intelligence, right? It go from primarily descriptive to predictive to prescriptive, all right? And now most of the business intelligence, most of the business analytics are descriptive, like about 75% are pretty much, I would say, all descriptive, just summarizing data that already exists. And about, I would say, 20% of them are predictive, and about like probably 5% are I would say, prescriptive, okay, where they start recommend actions. And so descriptive analytics, I'm sure all of you have a pretty good understanding of what it is, right? You've seen reports and dashboards of data, summarized in every imaginable way, right? In all kinds of different charts that you can imagine. Right? So basically, this is what descriptive analytics is, right? It's all about, and if you look under the hood, it's really simple. It's really just counting plus pretty reports, right? And if you look a little deeper, it does a little bit of arithmetic, some average and percentages, and some booleans and joints. And some companies or vendors, say that they do advanced analytics. Basically, just counting plus pretty report plus some kind of filter. Okay, so you can filter traffics from Europe, from Asia, from US, right? And then you count them up, and then you put them in a pretty report, and that's what people call advanced analytics, right? So all you need is really just data to do descriptive analytics. And typically the algorithm that's involved there is really simple. It's really a few lines of query or a few pages of query, right? It's something fairly manageable. And a lot of times when when data science become a hot topic, right? People say, oh, look at all this pretty infographic that people produce. They're produced by data scientists. So they're but this is not data science. Okay, this is just data itself. Okay, this is just data itself. Okay, it's a representation of the data. It's not actually data science at all. Okay, just data visualization. Okay, so I want to talk a little bit about predictive and prescriptive analytics in a little bit deeper, because a lot of people have misunderstanding of what predictive analytics is. Okay, most of you probably would think that predictive analytics is all about forecasting, right? Okay, it is, but that is only one of the applications of predictive analytics. In fact, it's the simplest. It is the most common application of predictive analytics, but it's the simplest one. Okay, I mean, an example of that would be a trend line. The simplest example would be a trend line, right? Because it tells you where the future trajectory of the data is, right? But in fact, what you are doing is that you're taking historical data, right? And this is the present time. You try to build a model where when you put in this historical data, it pops out some future data, right? Now, this future data here is a little bit of a misnomer, because future data doesn't exist. No one has future data. Okay, this should be a future prediction, right? And the difference is that it's very you can illustrate this, with a simple example of a weather forecast. Okay, so for example, you may, today's weather may be 62 and tomorrow's maybe 58, right? Now the difference between this 62 and 58 is that this 62 you could go out and measure it, and it will be somewhere in that range, right? But between 62 and 37, right? But these two numbers, 58 and 41. You can't measure that, right? So, I mean, where do these numbers come from? These numbers are actually not output of a measurement device, right? It's an output of some kind of model, output of some kind of computation, output of some algorithm, right? So they're not really real data in the sense that they're not actually measured directly, right? They're actually an estimate of what the temperature might be tomorrow, right? So now predicted data are not real data, because they're not measured and they're actually computed, right? So now why is this confusing sometimes? Because these data, 62 and 58, they store the same way, they retrieve the same way. People use them pretty much exchangeably, don't make any distinction between them, but there are actually a huge distinction between them there, which will be important just in a sec. Okay, so that's basically temporal predictive analytics, right? You're trying to predict in the time domain. But the general predictive analytic is actually not limited to time domain. Okay, so there, what you're trying to do is that you're trying to take data that you have to make an estimate of data that you do not have but want to have. Okay, so now as you can see, basically, the temporal predictive analytic is just one special case of this more general predictive analytic, right? It's just one instance of this type of general predictive analytic. The data that you have there are historical data, and the data that you don't have are future data that you want to have, right? In fact, you can never have future data, right? So you can only estimate it with historical data, right? So, so let me just give you a couple of examples of general predictive analytics. So I work a lot in my previous career on social media data. So, so one example would be, for example, scoring people's influence on social media. Right, so the data that you have are basically social media interactivity. You could get this data by scraping the web, scraping social media, or you could buy them, right? So you could get these data, right? You know, these data are like, you know, who retweeted whose tweet, you know, who liked whose tweet, who follow who respond to who, right? Who gave a thumbs up or a like to someone else, right? So all these are social media interactivity that you could get somehow, right? One way or the other, right? And then you put it into this model that you built, right? This model is a very complex algorithm, and then they outpop some kind of score, right? Say like between 0 and 100, and tells you how influential a particular person is on social media, right? Another example is, for example, sentiment analytics. I mean, do most people here know about sentiment analytics? Probably heard of it, sentiment analysis. Probably some of you have heard of it, right?
Yeah, people are nodding in the room, Michael.
Yeah, I know.
I see them nodding online.
Okay, good. So a lot of people probably think that sentiment analysis is something completely different, but it really is just predictive analytics, right? Because there, what you're trying to do is it's actually a general form of predictive analytics, not in the temporal domain, okay? But what you're trying to do there, you're trying to take data that you have, which are basically text, any text. Could be a tweet, a blog, or a comment, or an email, or a news article, anything, right? Any text you have, you put it into this sentiment classifier, right? And then it will tell you, the output of this model is that it give you a positive, neutral, or negative sentiment for this person about a particular topic or subject, okay? So that's it. I mean, so now keep in mind that this general predictive analytics there's nothing temporal about this, right? I mean, you could put, for example, historical data. You could put like, you know, Shakespeare's Hamlet in this sentiment classifier and see when Hamlet is positive or negative about life, right? But Hamlet is probably going to be pretty negative most of the time, right? But you could put like, you know, things that are in the past in there as well, right? So there are lots of other very useful examples. In fact, some of the most useful predictive analytics are not in the temporal domain, okay? Some other examples that might be, for example, gender inference, right? You could look at how people write, how people speak, and infer whether they're male or female, right? You could put but there's no time in that, right? You could put you know, for example, your grandmother's letters into this sentiment classifier and you know, accurately predict, you know, whether she's male or female, right? I mean, so I mean, the algorithm, you know it, but the algorithm may not know that, right? So the algorithm could do that, right? So there's lots of examples of this, right? So but as I said, the most common application is still in the temporal domain, right? That's in forecasting. So in our product, you know, we have Bayesian forecasters. These are actually, you know, predictive analytics as well. Okay. All right. So let's move on to prescriptive analytics, right? Prescriptive analytics. Let me just compare that with predictive analytics because there's a little bit of similarity there. Okay. So the simplest examples of predictive analytics is a trend line, as I mentioned before, right? But the general predictive analytics is not limited to time domain, right? If you've seen a couple of examples of that with sentiment analysis, influence scoring. I talk about gender inference, right? You could even do intent analysis, right? You could look at how people behavior online and infer their intent to purchase. You know, do this person really want to buy or do they not want to buy, right? So this is actually very, very useful in marketing, right? And you know, for a lot of business, and it's a big area of research right now. So, what is the simplest example of a prescriptive analytic? You know, what that you know of? Think about this for a sec, okay? It's a GPS, okay? It's a GPS navigation system, right? Because what does the GPS do? It's, you know, you tell them where you want to go and they prescribe you a sequence of action to get there, right? So this prescribing is telling you what to do to get to where you want to go, right? Now, as I said earlier, like Predictive analytics is all about estimation, right? Using data that you have to estimate data that you don't have. Prescriptive analytics, on the other hand, is all about optimization. Okay. Now, to understand that, think about, why do you think that this GPS prescribed you this particular route? Going from this, I mean, there's actually a lot of different routes that you could get from this, your start point to your destination, right? You could kind of go around here and go around, and then even go around. You could there's infinite number of routes. You can even kind of go around the Earth and come back on the other side, right? So why do you think it prescribed this particular route? Now, early GPS, what do they optimize? They optimize for the shortest distance, right? So the reason they prescribe a particular route is because that route is the shortest route from A to B, right? So, but nowadays, GPS got smarter, right? It takes into account of traffic, it takes into account of the modality of transportation, right? Do you want to take bus or do you want to take subway, right? So, but it's still optimizing for something, right? Today, most GPS, the smart ones, optimize for time, the shortest time, right? Time is the inelastic resource that we all have, right? So it optimizes for that, right? So you may actually prescribe you a different route every day, right? But it will be the shortest time to get from A to B, right? So just as in the case of predictive analytics, that's not limited to time domain, in the temporal domain, right? The general prescriptive analytics is also not limited to the prescription of route in geospatial domain either, right? You can also prescribe strategy or business actions that you could take, right? For example, some company may say, okay, I want to achieve 20% increase in revenue, right? So that's here. That's where you want to get to, right? And your prescriptive analytics system, if you have enough data, it may prescribe you what to do in order to get there, right? For example, you need to, if you have data about your marketing and how effective your marketing is, then you prescribe actions on, how much marketing you should do, where you should focus, and all that stuff in order to get to this 20% increase in sales. Okay. So, so what are some of the other examples that you know of that are prescriptive analytics? This one, I want you to think about this a little bit. And so one of the most common ones that, that a lot of us are very familiar with is search engine. Okay, why is search engine a prescriptive analytics? There's infinite number of web pages that you could look at, right? So why did it prescribe us a particular one? Because, so what, I mean, to understand why is it prescriptive analytics, let's ask the question, what is optimizing? What is search engine optimizing? They're optimizing relevance, right? It's the relevance to respect to your search query, right? So you tell me what you want, and I'm optimizing these ones. I recommend these content because it's the one that's optimized to the relevance of respect to your search query, right? Recommender system is also a prescriptive analytic. There's infinite number of movies or music that you could listen to, right? Why does it prescribe those movies for you to watch? Because it's optimizing something, right? It's optimizing the similarity of the content of the movie to your preference, right? Okay, so I'm sure you get an idea, right? So prescriptive analytics is all about optimization. To understand what prescriptive analytics does, just ask yourself, what is optimizing underneath? Then you understand what it's doing, okay? And in this case of predictive analytics, it's all about estimation, using data you have to estimate data that you don't have, okay? All right, so now you have a very brief history of business intelligence, going from descriptive to predictive to prescriptive, right? And you have a very good understanding of what predictive analytics and what prescriptive analytics is all about, right? So what's next, right? What's next? Now, to answer that question, we have to understand actually a little bit of. Hold on, this is actually missing a slide here. Okay. To answer that question, we have to understand what role do business intelligence play, historically in business, right? And the role that business intelligence play historically in business is what we call a passive decision support role, right? They are what we call passive decision support tools because they are passive in the sense that they don't make the decision for us, right? Because at the end of the day, humans still makes the final decision on what to do, right? So regardless of what the data tells you, whether it is descriptive, predictive or prescriptive, right? I mean, you could show you data, like for example, for tomorrow's stock market, right? How each stock performed, but you still decide what to do. You could just say, I don't believe that part, that one that says tomorrow a particular stock is going to increase 20%. You could not believe that. You could, and you could even tell you what to do, right? You could tell you, this is the route, the best route, turn left here, turn right here to get home, right? But you could say, I want to take a more scenic route, right? You could decide what to do, right? So it's passive in the sense that it doesn't make the decision for you, right? So now this is actually for a very good reason, right? Historically, why do humans always have the last say? It's for a very good reason, because as we all know, traditionally, machines are no match to human experts, right? No matter what kind of model we have or how much data that we have, machines are actually no match to the knowledge that's accumulated by a human over their lifetime, right? So now, why is that? Why is the traditional analytics have such these inaccuracy, right? So let's take a look at what happened historically, right? So our data volume certainly have increased, right? Went from bytes to kilobytes to, right now we are kind of in the petabyte range, right? In the future, we will, so everything is, right, today everything is stored on cloud. In the future, there will be quantum and holographic storage, where we get to the exabyte and zettabyte range, right? So right now, I think the totality of all the human data that we ever created collectively as a human race have the zettabyte range, but each company or probably are not there, right? So we probably today most company have in the petabyte range, right? So okay, so we also have a fairly good understanding of the models, the type of models that we can use, right? And it went from really simple statistical models such as linear model, logistic regression, and these type of things, right, to something very, very complicated, right? And obviously, the more complex the model you have, right, the more data you're going to require to fit those models, right? So when you put these data into this model, it crunch out some kind of analytic result, whether they are descriptive, predictive, or prescriptive. Now, the accuracy of these results, right, actually depend on three things, right? Obviously, it depends on quality of data, right? If you have garbage going in, then you're gonna have garbage coming out, right? And the second factor is the model's quality, right? If your model is completely missing a component, then then obviously it's not going to do very well, right? And the third thing is actually CPU cycle, right? You may have a really accurate model and you have lots of data, but you may not be able to finish computing it in any realistic amount of time, right? So they have to, in order to kind of make this practical, a lot of people just halt the computation, right? So at some point, right? So in trade-off that you don't get a very accurate answer, but you get it in time when you need to make this decision. Okay, so these are the three factor, right? So this is a little bit of just history again, right? So basically, back in the 50s, right, we actually already have a pretty good theoretical understanding of the model that we can use. So back then, neural network already exists. We already understand, how these 2 to 3 layer deep neural network actually work, right? Today, the neural network that we use in data science are much deeper, right? That's why they call it deep learning. It's basically a neural network that has, many layers, right? Instead of 2 or 3 layers, they have like tens and, not many companies actually do more than 100 layers. Okay, I mean, most of them are actually on the order of tens of layers. Okay, so this is where we are today. So deep neural network is basically a neural network that's deeper, right? This deeper is many more layers. That's it. Okay, so we have a pretty good understanding of these models, but what's limiting us back then is basically data. We don't have data, right? Even if the data actually exists, they're not actually digitized, so it's actually inaccessible for these computing machine to actually access those data, right? And the other thing is that we actually are limited by our computing power, right? We don't have, back then we actually used vacuum tubes, right? So over the next, I would say, few decades, right? I mean, our theoretical understanding, all three of these areas increases, okay? Our theoretical understanding of models increases, but it increases more or less linearly, okay? Whereas the amount of data and the amount of computing resources that we can get access to actually increases exponentially. And this is actually due to the Moore's law, you all know the Moore's law, right? Basically, computing power like doubles every 18 months, so that's exponential growth. So that means eventually it's going to overtake our understanding of these theoretical models, right? So by the 2000s, we already have distributed computing, right? What that means is that pretty much a company is going to, basically you have infinite amount of computing power, right? I mean, up to the amount that you have, I mean, not infinite, but I mean, basically it converts this computing constraint into an economic constraint, right? As long as you have money to buy more computer, you can have more computing power, right? So there's virtually no limit up to your economic constraint, right? So now in 2010s, right, there's actually GPU instead of CPU, right? We also have big data, and big data basically lift the constraint on data completely, right? So now you can have as much data as you want, right? So two of the three problems or constraints that limit the accuracy of analytics are gone, right? So what does that allow data scientists like me to do? Basically, we could use pretty much as sophisticated of a model we want, right? Pretty much we could use model that mimics our brain, right? Deep neural network is actually a model that simply a model that mimics how our brain functions, right? So we could use very sophisticated model. I mean, we could use like recurrent network, LSTM that mimics memory and all this stuff, right? So these are just different models that mimics how our brain thinks, right? So now the results of these analytics coming out of these models become very, very accurate, okay? Now, what happens when these results pretty much always agree with human prediction, human experts, right? Do humans always have the last say again, right? Because I mean, pretty much, when the model is good enough, what that means is that nothing is 100%, but most of the time, the model is going to make some kind of output, right? Produce some kind of output, and then the human expert is going to say, "Yep, I agree with that. I agree. I agree. I agree." Every time it's going to pretty much every time, nothing 100%, but pretty much all the time, the human expert is going to say, "I agree," right? So now this is obviously very redundant, right? I mean, why do you need a human there to say "I agree" every single time, right? Because so we could simply just automate this, right? Humans do not need to have the last say anymore. Right, we could just automate it. You could, but you just wasting a lot of resources and right, because when you automate it, you have to wait. You don't have to wait for a human to say yes in order to execute, right? But so your company can actually gain a lot of competitive advantage in time to market and time to execution, right? When you actually could automate a lot of these things, right? So okay, so that's actually the beginning of what we call artificial intelligence, right? Artificial intelligence is basically the automation of decision and proper execution of subsequent action. That's what artificial intelligence is, right? So to illustrate this in a picture, right? Going from from data to decision to action, that's always has been a human's job, all right? But today, if you automate this, right? If the model is good enough, such that that a human will pretty much agree with it pretty much every single time, right? Then you can automate this, right? And by then, going from data, the data is driving the decision, and the decision is driving the action pretty much automatically, as in a lot of the process automation, okay? And we already have this here today, right? For example, we have algorithmic trading, right? Instead of showing me data how the market is going to perform, right, and how it's going to trend, right, and just trade for me. Instead of telling me what to buy and when to buy, right, with prescriptive analytics and on the stock market, just buy and trade for me, buy and sell for me, right? You already know what the best is, right? So just buy and sell, right? I mean, I'm not sure how many of you are familiar with the robo-advisor, right? So I actually use robo-advisor to help me manage my finance. I don't have any time, to actually look at my investment portfolio, right? I just tell my risk profile, and then you just buy and sell for me, right? Why does it actually have to make me do the clicking, right? And say yes, yes, buy, and sell right here, right? It just buy and sell, buy, sell, right? So another example is automated loan origination, right? Once a person actually meets all the criteria, just give them the loan. Why do you need a human check off all these boxes and put a signature there, right? It's really not needed, right? So as I mentioned before, like the simplest example of a prescriptive analytic, right, is a GPS, right? So if we go back to that geospatial domain, right? Instead of telling me when to turn left, how far to go, before you turn right, right, to get home, just take me there, right? That's AI, right? This is the beginning of AI, right? So the automation of these decision and subsequent actions are what we call the nascent AI, right? These are the AI, basically, it's the beginning of AI, right? But AI are not all created equal, right? We have to ask the question of actually what makes one AI smarter than another AI, right? So if you ask this question of what makes AI smart, and do a little research yourself, very often you will find this image on the web, right? People will say that, okay, what makes AI smart is all this deep learning algorithm that's been developed in the recent years. And if you ask them what's deep learning, they're going to say, well, it's a kind of machine learning. What is machine learning? It's a kind of AI, right? This picture is actually incorrect. Okay, the reason this is incorrect is because the Venn relationship here is actually inconsistent. Okay, deep learning, I mean, it's incorrect, but it's not completely wrong either. So that's why it's kind of confusing for a lot of people. Okay, so deep learning, in fact, is a kind of machine learning. Okay, so deep learning is a subset of this machine learning algorithm there, right? But machine learning is not a subset of AI. Okay, it's not a kind of AI. Okay, however, machine learning is pretty much used in every AI, every modern AI today. Okay, so you put them in there, but these Venn relationships are actually inconsistent, right? Between this Venn and this Venn, this boundary here means a subset of, but this boundary doesn't mean a subset of, right? So this Venn diagram doesn't actually make any sense, right? I mean, it's like saying that, okay, the reason that it doesn't make sense because let me just give you another example, right? It's like saying that, okay, V8 is a kind of engine. An engine is a part of a car, right? So is engine a car? No, obviously engine is not a car, right? So machine learning is not AI. It's just used in AI, right? So engine is used in the car, but it's not a car, right? But V8 is a kind of engine, right? So the Venn relationship really have to be consistent for this diagram to make sense. Otherwise, it doesn't make sense. Okay, so you should just throw this picture away, right? I mean, this doesn't make sense at all. Okay. Yep. Okay. So let's take a look at what's a more accurate picture, right? A more accurate picture starts with big data, right? And data scientists, okay, like myself and my team here at Pros, are basically we turn big data into a model, okay? And we use a very powerful tool to do this, and that is called machine learning, all right? So machine learning here is really both a noun and also a verb. It's like Google, right? Google used to be just a noun, but today people are using Google as a verb as well, right? So same thing is happening to machine learning, right? Machine learning is both a noun and a verb. As a noun, machine learning is really just a bunch of algorithms that data scientists use, right? And as I mentioned earlier, right, deep learning is actually one kind of this algorithm, one of these algorithms of machine learning algorithm, right? So machine learning as a noun really should be called machine learning algorithms, right? Because that's what they are, okay? Now, but deep learning is actually not the only algorithm out there. It's a very popular algorithm because has a lot of success in doing something that's very challenging traditionally for machines, right? For example, image recognition, right? Speech understanding, and all this stuff that's actually requires I would say higher cognitive functions of a human in order to do, right? But because deep learning is as LSTM and these reinforcement, these are actually algorithms that actually mimic how our brain works, right? So it starts to able to perform things kind of like we do, okay? Now, but it also includes really simple algorithms such as this decision tree or something like that, okay? So, okay, so now that's what machine learning is as a noun, but what's machine learning as a verb? Machine learning as a verb is really just the process of turning data into a model. That's it, right? That's what data scientists do, right? We do machine learning because we turn data into a model, and depending on what data we have and what model we're trying to produce, we would pick and choose different algorithms or different combinations of algorithms to produce a model that we want, okay? That's what the machine learning is as a verb, right? So it's just a process, right, of turning data into a model, okay? Now, as I alluded earlier, right, a lot of people, one of the biggest mistakes that I encounter, I heard in the industry is that, oh, a lot of competitors will say like, oh, my models are built with machine learning, so I have AI, right? Not true, right? Now you know why, right? Because, just like saying that, looking at that, it's because the reason why people say that is because they look at that image that I told you not to remember, right? This image that I tell you not to remember earlier, right? This because they think that, okay, I use machine learning to build my model, and machine learning is a kind of AI, which is not true, right? So I have AI, right? So that's completely wrong, right? So machine learning is not AI, right? Part of this is also historical too, okay? Back in the 80s, okay, back in the 1980s, there's a kind of model that's called expert systems. Expert systems are systems or models that mimics how experts make decisions and solve problems, okay? So, but if, back then in the 80s, they were considered one of the earliest successful AI, back in the 80s, right? But, today, nobody considers this AI anymore. They just call them expert system, right? Because when you actually look under the hood, what these expert systems really do, it's actually just a bunch of if-then statement. It's just a very big tree of if-then statement. That's it. Okay, and for example, the expert system may mimic how a doctor determines whether you have lung cancer or not, right? Then the doctor is going to say, okay, if you have a chest X-ray, do you have nodules in the X-ray? If you do, then what shape is nodule? Is it round or is it irregular shape? If it's round, then you have to check whether it's growing faster than a millimeter a month, right? If it's growing faster than a millimeter a month, then you have tumor and you're probably going to die, right? If it's growing less than a millimeter a month, then you probably still have tumor, but it may be benign. You may be okay, okay? And if you don't have chest X-ray, then we have different paths of determining whether you have cancer or not, right? So this decision tree right here, right, is a very simple algorithm. It's really just a bunch of if-then statement, right? And everything is hard-coded, right? This decision tree, actually, all the condition, every branch, it could be a very complicated tree, right? I show like 4 layers here, right? It could be like 10, 20, 30 layer deep, right? This decision tree, right? Very complex tree, right? But everything is hard-coded, right? A fresh college grad out of college could code it up in a weekend, right? As if you give me enough time and give me all the condition in every branch, right? Everybody could code this up, right? So nobody considered this as a AI anymore, but back in the 80s, they were considered as AI, okay? So now, okay, so let's take a look at what really makes AI AI, okay? So models, as I mentioned earlier, once you have a model, the model will produce some kind of output, right? These are the results of the analytic that's performed in the model, right? And usually that will lead to some decision that need to be made, and some action that need to be carried out. And actions will have consequences, right? Will have outcomes, and these outcomes need to be essentially feedback into your analytic result in order for it to work, right? In fact, the feedback had to be in real time in order for it to work really well, right? So in fact, like pretty much all, all prescriptive analytics have to have a real-time feedback, okay, in order for it to work well. Okay, so think about this. I mean, as I mentioned earlier, what the simplest example of a prescriptive analytics is the GPS, right? So what is the real-time feedback in the GPS? What do you think it is? Think about this for a second, okay? It's that blue dot that tells you where you are, okay? Think about how good a GPS would be when you don't have that blue dot, or you don't know where you are, okay? When you don't have the real-time feedback of where you are, right? Whatever action they prescribe you to do, right? You're going to be very confused. If you turn left, I'm going to say, which street, this one or next one, right? So it's going to be very, very confusing. You'll get lost very, very quickly without that blue dot, okay? All right. So feedback is obviously very, very important, right? Especially in prescriptive analytics, right? Okay. So now let's take a look at who makes a decision, right? Traditionally, human makes a decision, right? What about actions? Well, I mean, actions today, a lot of actions can already be automated, especially these are the actions typically in the, I would say, in the digital domain, right? In the digital domain, because all that's involved is, execution of a bunch of code, right? So those can be automated already, right? But in the physical world, a lot of these actions still need to be carried out by human, right? Because we don't have robot didn't advance as quickly as we want to. Maybe that's a good thing. So anyway, so that's what happens today, right? Today, but what about feedback? So feedback traditionally is also collected by human as well. And human, we basically do surveys to collect this feedback. But as you know, survey is actually very, very slow, right? So we're not going to achieve this real-time feedback in order to make prescriptive analytics work well, right? So the first thing we need to fix is we have to essentially track this feedback in an automated fashion, right? They have to be tracked automated. And this can already be done in the digital world fairly easily. We just have to instrument it. We just have to write code to track it, right? But even in the physical world, it's starting to be possible and made feasible with sensors and IoT and smart devices, these advanced innovation, okay? So pretty much everything, all feedback in the future, right, can be tracked automatically with IoT, with everything, right? But today, right, a lot of it is still in the digital world, and that's already been able to track, right? We just have to instrument it, right? Now, as I mentioned earlier, again, right, if the model here, this model here, if it's good enough, then pretty much we can replace this human decision here, right? Because when I said, you know, the model is good enough, that means that pretty much every time the models produce some result, this human expert is going to say, I agree pretty much every single time, right? Nothing is 100%, but most of the time this human is going to say, I agree, right? So why, you know, make him, you know, sitting there clicking yes, 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 yes every single time, right? Just automate this, right? So now, whenever the human doesn't agree, right? I mean, he still obviously, you know, he has the power to kind of override it, right? So obviously, you know, the human can still override it, right? So therefore there's still a little bit of yellow here, right? That's not all kind of orange automated, right? But today, right, in the digital world, in the physical world, we can't get away with human carrying out this action. But in the digital world, most of these actions can already be carried out by machine, right? So now this feedback loop here, right, this real-time analytics feedback loop here, have pretty much no human in it, right, except in the cases where humans disagree with the machine, right? What does it allow this loop to do? This allow the loop to go really, really fast, right? Okay, so now this is a good thing, but there's still one problem. The problem is that now this model still, you know, never gets updated, right? The model is still the same model, right? If the condition is all the same, right, exactly the same, right, it's going to prescribe the same action for you it previously prescribed, right? Until the data scientists go and collect more data and go through this machine learning process to update your model, to improve your model, make your model better, right? This model is not going to improve by itself, right? Until data scientists do something with it, right? But one of the advantage of having this feedback loop, everything is tracked by machine, is that now everything can be digitized, right? Because everything is tracked by machine here, right? Everything, this feedback loop here is tracked by machine. Then everything can be digitized. Once they are digitized, they become data, right? Right? So if they are data, that means you could actually feed this data back into your big data store, right? Now your data changes, right? Your data is no longer the same data as before, because now your data actually has more data and new data, right? That gets added to it, right? Now, if you feed all of this data into your machine learning process or algorithm again, right? You get an updated model that takes into account of the new data, okay? So that the next action that you prescribe would be better than the previous one, okay? So now, basically, you could do this machine learning in a completely automated fashion, right? But you probably don't want to do this, right? Because sometimes machine can actually learn things that are actually wrong, okay? So ideally, we actually want to do this semi-automated, so the human actually can watch what the machine is actually learning, okay? And make sure that it actually learns the right thing, okay? So now, when you can do this really, really quickly, right? This every time you use the system, every decision that's been made, right, and it becomes new data, new action becomes new data, gets added to your big data store, right? And then through the machine learning process, it updates a model so the model becomes better than the previous one, right? If you do this over and over again very, very quickly, this model would become a very, very good model of this process of going from decision to outcome, right? This model will know exactly what kind of outcome you're going to get based on what decision or what action you take, right? It's going to be a very, very good model of this process, right? And this is what we call the learning loop, okay? The learning loop is actually what makes AI smart, right? it doesn't have to be perfect initially. The model just has to be good enough. Okay, good enough such that the human agree with human experts pretty much, a lot of the time. I would say like 90% of the time, right? Then you can automate this, right? Then once you automate this, everything can go really, really fast because now every decision that's been made, right, becomes new data and a new outcome that fed back into the model, right? Fed back into your big data store. And through this machine learning process, it will actually create an updated model that's better than the previous one, right? So even if the condition is exactly the same as before, right, the model is better. It may prescribe you a better action than the previous one, okay? So it keeps getting better, right? Every time you use it, it keeps getting better at what they're doing, okay? So that's the learning loop. So just to illustrate the power of this learning loop, this is AlphaGo. I'm sure some of you have heard of this in the news, that AlphaGo, this program, right, is able to beat the world champion in the game of Go, okay? And AlphaGo, ironically, he was not actually trained with strategies from this world champion, but they were trained with like strategies and gameplays from players they're professional players, right? But they're actually nowhere near, the world champion, right? So, but once they train AlphaGo to be good enough, so they actually could play a real human, right? In a way that is pretty good, right? Then what they can do is that they can actually make AlphaGo play against AlphaGo itself, okay? Now that's really interesting, right? So now this thing can go really, really fast. So if you play against a human, right, it takes like several hours to play just one game, right? But if you make AlphaGo play against AlphaGo, you could play 1 million games in a day, or even more. I don't know how fast. Just if you want to play faster, just give it more computer, right? So what is the implication of this? The implication is this: now AlphaGo can make all the mistakes that a human can ever possibly make in their entire lifetime, probably, right? And probably 2 or 3 lifetimes, right? So AlphaGo, can learn from all those mistakes and get better and better and smarter every single time, right? And that's actually how AlphaGo is able to beat the world champion, right? So this is actually, a pretty amazing story, right? So because of the learning loop, right? There's actually lots and lots of different applications of AI. Pretty much, there's, as long as we can digitize the data and have the data to train the AI, we can actually have a new application in AI, right? So, but there's actually 4 major applications of AI in the industry in the recent years. Okay, so these are the 4, I would say, the big 4 categories. Okay, the first one is what we call perceptual AI. Perceptual AI are sometimes they call cognitive algorithm, cognitive AI. Okay, so there's different names for it. Okay, are basically AI that mimics higher kind of perceptual cognitive functions of a human, right? For example, in speech processing, image recognition, these are the examples of it. And the applications of these are primarily in what we call human-computer interaction, HCI. Okay, and some examples of this you've seen it all is in Siri, Alexa, and Google Assistant, right? These are chatbots and digital assistants, right? So the application is pretty obvious, right? If you have a machine that could see things as we do and talk back to us using our language and understand how we talk and how we, right? Then of course you're gonna interact with the machine much better, much more effectively, right? And okay, so that's first class, right? First major applications of AI, right? So these are what we call perceptual AI. The second application is what we call internet AI, right? So these are applications on the internet domain. Basically, the biggest application there is the recommender system. So Amazon's basically their recommender system, right? People who buy this also buy that, right? That's a famous use case, early use case, right? Netflix is also one of the pioneers in this area as well, right? So basically these internet AI, right? What do? They, through every usage, right? It's going to learn your preference and what you like, what you don't like, better and better, right? And be able to recommend better and better content over time, right? So it's very easy to understand. Personalization engine, right? So the third class of big applications, the third big application of AI in the recent years is autonomous AI. So these AI are, obviously the biggest application there is the self-driving car, right? Or any autonomous vehicle, any autonomous machine. Obviously, it also has a lot of, I would say, applications in advanced robotics and connected machines and IoT, right? Because it's all about machine talking to machine, or parts or components of a machine talking to components of the machine, right? In a way that allow them to function autonomously, right, and make decisions for itself, right? So so that's basically autonomous AI, right? Just all about big application there is autonomous vehicle, right? So the last category is what we call business AI. So business AI, the biggest application is in business decision and automation, and these tend to have I would say a very high degree of specificity to the domain. Okay, for example, you see applications such as algorithmic trading, right? Machine-aided medical diagnosis, right? So Watson actually do a lot of these machine-aided medical diagnosis, right? Recommending treatments and all that stuff, right? So drug discovery. So PROS is also one of these business AI, right? Because we automate the decisions of how to set your price and what opportunity to go after, right? So that's what PROS do, right? We do business AI, right? Okay. So because AI is such a hot topic today, right? There's pretty much every vendor out there is going to say they do AI, but if you actually look at what they actually do, right? You will actually understand whether this is actually going to be a useful application or not. Okay. So traditionally, no matter what kind of technology company you are, you always have some kind of I would say some traditional or legacy business logic to address some kind of business problem, right? Otherwise, you wouldn't be in the tech space, right? And what people do is that they would just say, okay, now I could put a perceptual AI on top of this business logic, right? Then my system has AI in it, right? So that's actually, it's not a false claim. It's actually a real claim, right? Because perceptual AI is actually one kind of AI, right? It's one kind of AI, right? One application of AI, right? So now,
Aptus.
Hello? Is that a question?
Aptus. I was going to say that's Aptus.
Yes,
their agent.
Yes, okay. So basically, perceptual AI is one kind of AI, right? But if you understand the learning loop of how AI actually work, right? What is this AI going to do for you, right? The application of this perceptual AI is in human-computer interaction, right? So the more you use this system, the more the system is going to understand you, it's going to interact with you better, right? So these perceptual AI, you put a chatbot on top of this legacy system or put a digital assistant on top of it, right? Basically, this system is gonna learn the way you talk, right? Learn your specific business domain jargons, right? And you may even start to understand your accent and everything, right? So you will understand you really, really well. But what's actually solving the business problem? It's still the same old business logic, right? That part hasn't changed, right? You just enable the human to interact with the system better. That's all, right? Now, that is not to say that these perceptual AI don't have value. It certainly have value. In fact, pretty good value too, right? The value is increased employee productivity, right? Now instead of standing in line waiting for your coffee, you could set up meetings, right? Or tell your digital assistant to fetch you some data, right? But what's underneath it is really just a query, right? To fetch your data, right? It's just a query, right? If I say fetch me data, then you just run this query, right? It's the same old business logic, right? But it does increase your employees' productivity, right? Which is valuable, right? In some sense, right? But how is PROS AI different, right? PROS, we have business AI. Our business AI directly solve the business problem, right? So now if you understand the learning loop, basically every time you use this business AI, it's going to solve your business problem better, right? The more you use it, the more it's going to set your price better over time, right? The more you use so let me just use opportunity detection as an example, because that's easy one to understand, okay? So opportunity detection, it recommends you opportunity to go after, right? For which customer, which region, which, when, at this time, right? These are the product you should sell to this customer, right? All right. So we recommend a bunch of opportunity, but based on which one the sales actually accept and reject, right? It's going to recommend better one for the sales in the future. In fact, eventually you will actually look at the outcome, right? Maybe you accepted a lot of one that you can't close, right? Then over time, it's going to learn that it's going to actually recommend you opportunity the one that you actually are able to close. right? So it's solving your business problem better and better every single time you use it. Okay, so the value proposition there is days and nights different, right? The value proposition there is actually a smarter and better business decision. Okay, so now being a data savvy company, right? I mean, actually, most of the data savvy company actually have probably innovate in all four of these categories of AI. For example, like in Amazon, right? They have their Alexa, their perceptual AI, right? They have their recommender system in their Amazon.com, right? Very famous one, right? They also have autonomous AI too, right? I mean, have anyone actually visited the Amazon's like fulfillment center, their warehouse? You see that the fulfillment center actually have very little human in it. A lot of it is just robots. These carts. They're robots, essentially robots. They just shuttle products around the factory. And so all those are basically autonomous AI, right? And also Amazon. They also have their dynamic pricing. They set their prices very dynamically to match the market demand. Okay, so pros also have being a data innovative company, right? We also do a couple of these as well, right? So we have our core is actually our business AI, right? That's our core. We've been doing that for 30 years, right? But we also have a perceptual AI too. And that's Monet, right? So now Monet is different than any other digital assistant or chatbot in the way that because she have access to these business AI, right? That's what makes her smarter, because she have access to these business AI underneath it, right? It's not that she's any different than Alexa or Cortana or any other these digital assistant. It's because she have the access to this business AI. Okay, so that's essentially how we're different in the market. Okay, so now maybe let's take a pause here and see if anybody have any questions so far.
Okay.
It's about an hour already. I have a few more to go, but just thought maybe a good time to kind of pause a little bit.
All right. I'm going to unmute the phones just for a minute. And sorry. And if anyone has any questions, please feel free to speak up.
No question.
Hey, Michael. This is Cynthia West.
Hey.
Quick question. About a month ago, IBM Watson got some bad press about making incorrect medical diagnoses. I mean, did you read that, and can you comment on it?
Yes. Actually, that actually goes into the next part. So maybe I will.
Okay. Well, then don't worry about it. Don't worry about it. I was. Okay, cool. And maybe this is in the next part too, but people like Stephen Hawking and Bill Gates and others are concerned about what they call that technological singularity. And AI kind of creating a mind of its own or taking over or surpassing humans. I mean, what are your thoughts on that?
Okay, so that one. Okay, so I'll take these two questions later because it will come. It will come later. Okay, and this is actually I gave a talk to a bunch of UC Berkeley incoming students, and that was the conclusion. I will tell you that later. Okay.
Okay. Awesome. Yeah. Thank you so much.
Yeah.
Hey, Michael, this is Shane Kirkpatrick. I just have just a comment and just want to make sure I'm clear on it. So what you said in the last slide was that pros not only solve the business problem, but it also improves the interface and the productivity of the employees?
Sure. Yeah, if you use Monet, right? If you don't use Monet, right, it doesn't, I mean, obviously, if you don't use Monet, right, obviously you could improve the productivity in other ways by designing your UX and UI better. But that's actually a very natural way, right? Because if you're using AI, one of these perceptual AI, it's actually a very natural way for people to work with other people, right? So you just talk to them and tell them what you want, right? So yes, if you use Monet, right, you could definitely improve your employee productivity as well, right? Just like these other perceptual AI. Does that address the question?
Yeah, thank you.
Great. Any other ones before I go on to address the two very challenging questions Cynthia posed?
Yeah, this is Rajiv Kumar here. So one question on the learning loop itself. Just want to make sure I understood that. So
yes.
when you talked about what makes artificial intelligence intelligent, it's about sending the outcomes back to the data. But then on the model side, does the model itself get adapted, changed with different models?
Yes,
or does the
they
model
do.
also say the same?
The model changes itself, right? Essentially through this machine learning process. Right, this machine learning process is what actually, now your data change, right? If you feed that data into your machine learning process, right, in a way that's, I would say, semi-automated way, right? We don't want to, as I mentioned, you don't want to do this completely automated, right? I mean, let me just give you an example why, complete automation is actually a bad idea. This is a example that I use a lot when I give talks at conferences, and is that there's actually it's actually a real story. Where a bank tries to use this machine learning, this black box, they call it black box machine learning, right? This the neural network, you can't really explain why it works, what it does, okay? To create an algorithm that actually give people loans, right? And to actually compute, what it actually do is it computes the loan default probability of each individual. And what the data that they feed them is basically all the demographic data, like their age, everything, right? They could get on this person, right? Their income, obviously, all the spending pattern and everything, right? But everything else that they could get about this person as well, right? So what happened is that this machine learning algorithm basically picked up that race is actually highly correlated to people's default rate. Okay. So, but we can't use race to lend people, right, as an attribute to lend people money, right? That's illegal, right? I mean so this is where humans have to come in and say, okay, whatever variable 276 that is, right? That one we can't use because that's actually race, okay? So we have to kind of remove that and make sure that the machine don't use that, even though it may actually lead to better profitability, but it's illegal. Okay, and the machine doesn't know what legal or illegal is, right? So you still need some human supervision. Okay?
Okay, thank you.
Okay, all right. So any other questions before I move on to the last part? No questions? Okay, maybe there will be more when I go into the last part, okay?
Hey,
so,
Michael?
Yeah.
Pause for just a minute. I'm going to mute everybody and then unmute you, okay?
Yep. AI trend. Right? How can a company take advantage of this AI trend? So, how many of you actually have used this GPS called Waze? I'm sure some of you have, right? Some of you probably know people who use Waze, right? Okay, so when you use it very early on, right? The first time or first few times that you use it, right? Do you find it kind of strange that you actually direct you to this kind of blind alley this route that you never take before, right? And you find it kind of strange, right? I mean, this is an experience a lot of people who use Waze will experience, right? It's like, wow, it's telling me to go. I give them a destination, and it's telling me to go something that's totally kind of not what I would go, right? It goes into this small, tiny little street that you never go, right? But then so you ignore it a few times, but then after a while you try. Okay, I have a little bit of time. I could, I want to try it and see, see what does that lead, right? And guess what? When you follow Waze, you get to your destination earlier. You get to your destination faster. Okay, so this is how you kind of develop this trust, right? You learn to trust. Hey, Waze really is saving me time. Okay, so now this is actually a problem that I encountered when I was speaking at a conference in Istanbul. Yeah, so I need to actually get across the Bosphorus Strait, right? From this green dot to this red dot, right? Now, basically, once I key into the GPS, it tells me to go on this roundabout way, okay? Now, this is really strange, right? Because, why is it strange? Because, even though I'm trying to get to the red dot right here, right? I'm actually spending more time getting away from it than eventually, spending my last third of the time getting close to it, right? Now, this is a little bit counterintuitive, right? I'm trying to get there, right? So if I don't know the geography, right? If I could see that, okay, there's a landmark across the strait, right? I mean, if I'm not right on the coast right here, right? If I don't know the geography, I may be very tempted to say, okay, I'm trying to go to that tower across, I could see it right here. Why is it telling me going further and further away? It's telling me, if this trip takes me like, takes like 2 hours, right? It's gonna, for the first like 1.5 hours, it's telling me to go away, right? It's moving further and further. This is really, really weird, right? But if I don't trust it, what will happen? If I say, okay, I'm not going to trust this GPS, I'm just going to go towards what I see. I saw it, I can see it there, right? And what happened is that you're going to run into water eventually, right? And then you're going to have to turn back again, and you may end up getting to your destination much, much later than you want to, right? Okay, so we understand that, we should follow the GPS because we understand how geography works, right? We understand how the geographic limitation, we can't, unless I swim, I'm not going to be able to go across the Bosphorus Strait, right? Or take a ferry or something. In fact, if I take a ferry, it's actually slower, right? Because I had to follow the schedule, right, at that time. So now, what if this was in the domain of, say, financial domain? What if it's not in the geographical domain, it's financial domain? This is a problem that, what if you want to invest, say, $1 million and get 400% return? Basically get to positive 3 million in 6 years, right? So you sink in $1 million, you want to get back to this point in 6 years, okay? Now, what if you have to lose 2 more million to get back those 6 million, to get back to positive 3 million, right? That's not very comfortable, isn't it? That's actually pretty scary, right? It's not very easy to sell to your boss or your, right? It's now, what if you kind of, okay, let's say if we specify some constraint, right? We say, okay, like let's not lose more than $500,000 at a time, right? What if the prescription was this? Right, you don't make any money, right? And until the last like 6 months, right? Then you make it all back, right? Doesn't feel very comfortable, isn't it? Right? So this is actually, but the problem is that what if this was the only way, right? And if you don't trust it, you risk, not trusting the GPS and running into water and getting to your destination even later. If you don't trust it, maybe you will lose all the money. What if this is the only way, right? So this is actually really, really a big challenge for people, right? So one of the biggest challenge for using AI to realizing the power and benefit of AI is this trust issue. It's because people don't trust issue. This actually brings Cynthia's question back, right? Nothing's perfect, right? I mean, AI, they have is a model. It's probabilistic in nature, right? So there is some chance that it could make a wrong diagnosis, right? And so that actually, is what makes people afraid of these AI, right? Because we don't trust them. We don't know what they do, so we don't trust them, right? And that's actually limiting the value that we can actually derive from AI. Okay, so to comment on that, right? What should doctor do? Should they just not use AI, right? I would say not. I would say that you should just have a better process in checking what the AI actually do, right? So traditionally, how people build trust with these machines is that they do this kind of blind analysis, right? Basically, almost like a double blind, right? Basically, the doctor will look at your, for example, chest X-ray or something, and then the machine will look at it again, right? But each one of them will make an independent diagnosis of whether what's happening, right? And then after they collected enough samples of this, they will compare and see what's the accuracy rate of these machines compared to human experts, right? And when the human experts and machine disagree, right? In the cases where they disagree, they will get a third human expert in to see whether the machine is right or better, more senior expert, right? To see whether the human is right or the machine is right, right? But ultimately, this is still like even the human is not perfect sometimes, right? But at least, you know, when the human made a mistake, you could, you know, you could blame the human and fire them, right? But with a machine, you can't. You know, like, who do you fire? you know. So this is actually something very challenging today. I mean, this is actually an area that like, you know, I got asked a lot of questions about this, you know, speaking at conferences and panels and stuff like that. Unfortunately, there's actually not a very good solution yet. What the best solution is, basically they do what we call confidence interval check, right? So if the machine is like 99% certain that there's no cancer, right, or then it's gonna say there's no cancer, right? But if it's like, say like even like 98%, you know, then basically it's gonna give it to a human, right? The human's gonna check it and see whether, you know. So basically, this is the way to kind of get around it, right? So they have a better process around it, right? So you could set your threshold, right? Depending on, for like medical diagnosis, maybe the threshold will be very, very high. So 99.999, right? But anything that any slightest uncertainty, you give it to a human, right? But for some other things, you maybe, you know, maybe 90% or 95% is good enough, right? Maybe so you could set your threshold, right, to build in that process to check. Okay, so does that address your question, Cynthia? Okay, the first question at least, right? So let me move on then. Okay.
I think so.
All right, good. Let me try to address the second question as we move on, okay? So basically, you know, in the geographic domain, right, we understand how geography works. So we can trust a GPS, right? But in these, I would say some other domains, like whether it's financial, medical, or some other domain, right? The landscape could be so complex that even if we look at it, we don't know what the best route is to get there. Okay, and we just have to trust AI, because they have a purview of the entire landscape and they know how to get there, right? I mean, so not only do we have to not fear AI, we have to learn to trust AI and work with them in order to realize the benefit from them, right? Just imagine, like, you know, you have a price recommendation, right? What happens if your people just don't trust it, right? Obviously, they're not going to realize the benefit from it, right? Okay, so now another thing that's really, really important is that, you know, is garbage in, garbage out, right? As I mentioned this a little bit earlier, right? So basically, what an AI is basically just an automation of these results coming from your analytics, right? The decision and action following that, right? That's what AI is. Now you know that. It's really, really simple. What happens when you have garbage going in, right? Your analytic result is going to be garbage. So what you're automating is basically a bunch of garbage stuff, right? So basically, your AI is only as good as your training data, right? So the question is, what do you do, right? Where do you get your good training data from, right? I mean, this is actually a question a lot of a company are struggling with, is that basically they don't have good data to train the AI, right? So basically, this is actually leads into another completely different set of workshop that I have on digital transformation. Basically, you have to start digitizing your business, right? You have to turn all your business process, communication, operation into digital process that you can track, right? Because as you see in the learning loop, right, if all the entire the analytic feedback loop, not the learning loop, okay? Even the learning loop is also a feedback loop, right? The analytic feedback loop, if once everything is able to track by machine, automated by a machine, right? You could track them, right? And they become digital data that can be added to your big data store, right? And then that actually goes into your machine learning process and update your model, right? So that's actually very, very important. So you need to do that for all your business processes, right? So that means you need to start your digital transformation in your business. And digital transformation is a buzzword, but at a high level, it's really, really simple. It just means the adoption of digital technology to change how your business operates. That's all, okay? The reason why it is so confusing is because there's lots and lots of different digital technology out there, right, for you to adopt, and each one of them can actually change how your business, different parts of your business operate, right? So I mean, for example, people can use social media to engage their customer, right, in marketing, right? So that's using a digital technology, social media, right, to change how they do marketing, which is changing how your business operate, right? Changing one part of your business operate, right? And people could even use, I mean, in the case of pros, right, use big data, right, or revenue management system to or dynamic pricing to help them change the way they do sales, right? So that's using, again, another digital technology, right? Real-time dynamic pricing to change the way they operate their sales operation, right? I mean, you could even have a really simple kind of example of transformation would be like, for example, using an iPad to onboard your employee, right? An iPad is a digital technology, and you're using that to change how you onboard employee, which is your HR operation, right? So that's, all of those are examples of digital transformation, right? But there's actually many, many more, right? You could go into it. So that's the reason why digital transformation is so confusing and so different from every company to every other company, is because there's so many different technology that you could adopt, and each one of them can change a different part of your business, right? And people are using it to change how different parts of the business operate, okay? So obviously involve technology, but ultimately it involves people, process, and ultimately the culture as well, right? But it also requires good strategy, program, and execution. Now this is again, like I said, it's a different talk that I won't have time to go into. So a lot of people often ask me like, so what can AI do, right? So I basically tell them, you know, don't ask that question. That's a wrong question to ask, because AI can pretty much do anything that we can do, as long as we can fully digitize it, right? Because as long as we have the data to train the AI, basically we can, the AI can actually replicate what we do, pretty much. Okay, so that's kind of the end of the talk, but the other part actually goes into IoTs and stuff like that, which I don't plan to go into with you guys. Now, to address the last question of this technology singularity, right? Basically, AI basically learns from us, right? Our decisions and our behavior ultimately create the data that they learn from, right? I think the best way to essentially prevent us, you know, these robots, AI, you know, killing us, taking over us, right, is that we have to be better human, right? We have to be exhibit more empathy, right? It's not just about killing our competitor and all that, right? Sometimes we need to exhibit a little bit of human empathy, right? Otherwise, our decision and our behavior will be reflected in our actions, and guess what? You know, these AI and robots, they're going to learn from our action, and learning for these entities is complete. Means they will learn everything. They won't just learn what you want them to learn, right? They will learn everything, right? And they will basically, you know, learn that, you know, like the way to kind of optimize profit is to, you know, kill your competitor, right? What if human become the competitor in the future, right? So the only thing we have to fear is ourselves, basically. So that's kind of like my.
I feel better.
Yeah. So. Okay, so just let me illustrate this. I mean, this is the kind of conclusion I give to the UC Berkeley students, you know. But I just wanted to have a little bit deeper. That's a good kind of message for undergraduate students. But for us, I think, you know, we can have a more practical look as well, right? Basically, as AI automates more and more of our tasks, right, it just shifts the humans to do more and more downstream, right? So let's look again at say opportunity detection. Okay, so in the case of opportunity detection, okay, traditionally before opportunity detection, how do sales decide what opportunity to go after, right? Some of them may go with guts, right? But some of them go with the experience. But what is experience? Experience is really data in people's head. That's what experience is, right? But people forget, you know, sometimes, right? So that's why we need basically computer to help us, you know, store all this data, and CRM to track our opportunity, our leads, and stuff like that, right? So because they don't forget, right? So before we have opportunity detection, our sales basically have, if they want to do a good job, they would look at all the CRM data, all this, you know, data in order to determine which opportunity to go after, whether there's a gap, whether there's some anomaly, right? The exact same thing that our opportunity detection automates today, right? So today we automate that. We automate that human looking at data process, right? And basically we just give a recommendation. This is the opportunity that you should go after, right? So now it just shifts the human's job further downstream, right? Instead of looking at it, you don't need to look at the data anymore because that data, we have algorithm and AI to look at the data already, right? You just have to accept and reject, right? Okay. In the future, when opportunity detection becomes good enough, you can automate that as well, right? It would just automatically create an opportunity for you and reject the one that doesn't fit you, right? So what do humans do? You go downstream. Now you just go write the email, right? And send to the ones that, you know, that opportunity that the machine actually recommended for you, right? And in the maybe even further future, right? Even the email can be automated too. Machine can actually start writing email automatically for, right? Then what does it do to human? You just go further downstream. You just have to go to the meeting, right? If the computer will actually automate your emailing and all this stuff, right? And then and set up the meeting, right? And you just have to go meet the customer, right? So basically, the more it automates, it just simply shifts the human's task further and further downstream, right? So that we could do more meaningful stuff that human should do, right? Basically, I would say that, you know, those who fear computers is going to take over their job, I tell them one thing. Basically, you know, humans have been doing too many boring, mundane tasks that should have been done by a machine a long time ago, right? So that's kind of my answer to that. I mean, hopefully that addressed both of your questions, Cynthia.
Yeah, you're scaring me now because we're relying on a more optimistic view of human nature.
Yes, and I think that the human race will eventually learn that, you know, to best ensure our survival is that we need to be better humans. So I mean, it's one of those things that I felt that, you know, it's a little ironic, you know, it comes to that conclusion, basically that, you know, all our behavior and all our decisions are reflected in the data that's been tracked and generated, right? And then that's what actually ultimately what feeds the AI and these autonomous systems, right? So they will learn, and they will behave more and more like us, and you know, so they, you know, yeah, I mean, we kind of have to exhibit, you know, basically treat them like essentially our children, right? Basically, we have to be a good role model for them, as we are for our children, right? The difference between this AI child and our human child is that, like I said, right, these AI, they, like, you know, the learning is complete, right? Learning is, they don't just learn a subset of stuff that we want them to learn. They will learn from everything that we do. And yeah, and they never forget, right? So yeah. It's a scary future, but I think there's still hope. We
have to take that view. I think that in the past, it's always seemed like technology, you know, as technologists, we promote and advance technologies before we consider the social and ethical implications of what we're creating. And so we're always backtracking, and it takes longer for politicians to kind of catch up to what we're creating as software and technology people. So yeah, that is something that a human problem, right? I mean, politicians are staying in power for too long. I think they this learning loop doesn't go fast enough for them to be update their knowledge and replace them fast enough.
All right, Michael, we have time for one more question, and it's from Rajiv.
Oh,
okay.
Just a quick question on the terminology that we all covered here in terms of learning loop, the definition of a model change, the definition of these 4 categories. Are any of these kind of pro-specific, or are they widely accepted across data science?
Well, I mean, the thing is that, like, there's no really any standard, you know, just know what they are. I think what you call them is really, I mean, like I said, you know, some people call this perceptual AI, some people call them cognitive computing, cognitive AI, or something like that, right? But you know what they are now, right? The important thing is to understand what they are, right? And be able to defend what you call them, right? You could call them, if you want to call them cognitive AI, sure, call them cognitive AI. Just that they are basically these AI that mimics human perceptual functions or cognitive functions that, you know, the application has been mainly in, you know, human computer interaction. And some examples of these are, you know, these stuff that you're familiar with, right? I think these are, the learning loop is kind of my my term. I use that, you know, like basically other people just call them like feedback learning loop or something like that. So some variants of it, but user feedback loop or something like that. I like to call it a learning loop because that's what makes AI learn. Okay, this learning loop is actually, what does learning mean? Learning means that, you know, through usage and experience, right, the model become better before. That's why you learn from those data that you collected from the outcome and feedback, right? So it learns, incorporate those data into the model, so the model gets updated and becomes smarter and better model than before, right? That's what learning is. Okay, so as you can see from this picture, right, machine learning is used in AI. This is actually a very simplified, I would say, architecture of most AI system, right? Machine learning is definitely a part of it, right? Is used in it, but machine learning is not AI. Just like, you know, an engine is used in every car, but the engine is not a car. Okay, same analogy, right? So that picture, that, you know, very widely popular picture that a lot of people use, should be thrown away. Okay.
Makes sense.
Michael, thank you so much. This has been fantastic.
Okay, I'm glad.
We'll schedule you later, and maybe we can schedule a part 2. Okay.
All right. Yeah, that's helpful. I'm certainly happy to go through some other stuff. Yeah, I have lots of different content. Yeah, depending on what you want to learn.
Okay. Thank you, everyone.
All right. Thank you. Bye-bye.